Tēnā koutou. Hello everyone, I'm Vijay. So this is what lots of people think a scientist is. Cool person with a lab coat, doing experiments, discovering new stuff. But in reality, scientists more often get up, realize they have a Zoom meeting in 5 minutes, and then the boss tells them they have to work on writing a new grant instead of working on their research. Scientists are just normal people with normal jobs and maybe more advanced degrees. Like other normal people, they have paperwork and deadlines. Some of them need coffee to get up in the mornings. Some of them have long meetings. Some of them commit fraud. And unlike other people committing fraud, when scientists do it, there can be some pretty bad consequences. Like this guy here, Andrew Wakefield. Kind of a famous example. In 1998, he led research for a paper which claimed that the measles, mumps, and rubella vaccine was associated with developing autism. In 2004, 6 years after the study was first published, a journalist did an investigation and uncovered a lot of dodgy stuff. But the paper wasn't fully retracted until 2010, when he was struck off the UK medical register for over 30 charges of professional misconduct. It turned out Wakefield didn't get his research approved by an ethics committee. He didn't get anyone to confirm, "Oh yeah, you're not violating any human rights, you can go ahead." Probably because they said hell no, considering that he selectively chose 12 developmentally disabled children and fudged up their diagnoses and medical histories to make them fit the results he wanted. He even bribed kids at his son's birthday party to let him take samples of their blood. All this and more let him conclude that a group of previously normal children had symptoms associated with receiving the vaccine. That's an important word, by the way. Associated. Wakefield didn't say the vaccine caused autism, but most people didn't read the research study itself. So, when he was really insistent that the MMR vaccine was linked to autism and that it shouldn't be used until further research was done, they believed him. And why would he do all that? The answer is simple. Money. The journalist found that Wakefield was paid over $750,000 by a lawyer who wanted the study as evidence to sue the MMR vaccine manufacturing company. He also wanted to sell his own MMR vaccine. And the thing is, that was a flat-out malicious case. In real life, it's much more common for people to make mistakes. They'll say the results show one thing when they're actually showing something else. Simple statements can have extremely specific statistical interpretations. Or sometimes people do intentionally manipulate things, but instead of making things up, they'll try to overstate what the effect of the treatment actually is, like in this XKCD comic. These scientists didn't find a link between jelly beans and acne. This statement, p-value over 0.05, means that if there's no link between jelly beans and acne, they could get a result as notable as theirs in more than 1 out of 20 experiments. To find a link, they want a result they could only get in 1 out of 20 experiments or less. And look what they did, 20 experiments. They selectively chose an experiment where they did manage to get a 1 out of 20 level notable result. Now, unfortunately, this is pretty common. It's hard to publish a paper without notable results, and the scientist boss will not like it if they don't publish anything. It's led to a replication crisis, where results can't be found again. In 2015, the Reproducibility Project looked at 3 psychological journals. They found that 97% of 100 studies reported significant results, but when they redid the experiments, only 36% did. That's a lot of questionable evidence out there, but it doesn't mean that science sucks. It just means we need to be careful about it. We have to understand, science is done by normal people with normal jobs who sometimes lie and make things up or use questionable methods. It isn't really the truth, it's just the best understanding we have so far. We should be ready to judge whether new knowledge is any good and update our own knowledge if we need to. So, next time you see some weird claim, have a think. Can the person back up what they're saying with scientific evidence I can read about for myself? How's the quality of the evidence?